U.S. hypersonic race. Lockheed bets on affordable glide body. Lockheed Martin has unveiled a new hypersonic glide body designed from the ground up to be manufactured cheaply and at scale, announcing a weapon it calls the next-generation glide body that promises greater range and speed than existing American hypersonic designs, while costing significantly less per unit to produce. The announcement, made June 24, 2026 from Huntsville, Alabama, where Lockheed Martin operates its Strategic and Missile Defense Systems division, comes as the United States races to close a gap with China and Russia in fielding operational hypersonic weapons at meaningful quantities. A hypersonic glide body is the unpowered warhead section of a hypersonic weapon system launched by a rocket booster to extreme altitude and speed. It then glides through the upper atmosphere toward its target at velocities exceeding Mach 5, roughly 5 times the speed of sound, or approximately 6,125 km/h, 3,806 miles per hour, maneuvering along the way to defeat missile defense systems that rely on predictable ballistic trajectories to calculate intercept solutions. The combination of speed, altitude, and maneuverability makes hypersonic glide vehicles among the hardest targets for existing air and missile defense networks to engage reliably. The next-generation glide body, referred to internally as NXGB, differs from earlier American hypersonic programs primarily in its design philosophy. Previous hypersonic development programs, including the Army's Long-Range Hypersonic Weapon and the Navy's Conventional Prompt Strike program, both of which use the common hypersonic glide body, developed by Dynetics and Sandia National Laboratories, focused on achieving hypersonic performance as the primary engineering goal, with cost and production rate treated as secondary considerations. NXGB inverts that hierarchy, starting from manufacturing requirements and working backward to the aerodynamic and materials design approach Lockheed Martin describes as a manufacturing-first design methodology. The company says this approach delivers greater range and velocity than current designs while reducing per-unit costs, though specific performance figures and cost targets were not disclosed in the announcement. The program has completed its preliminary design review, a formal engineering milestone in American defense development that confirms a weapon's design meets established criteria for performance, manufacturability, and cost before the program proceeds to more expensive development phases. Completing that review positions NXGB for a flight demonstration scheduled for 2027, which will validate the performance claims the design has generated on paper and in simulation against actual flight conditions. A successful 2027 flight test would represent a relatively compressed development timeline for a hypersonic system, reflecting Lockheed Martin's stated intention to leverage existing proven technologies rather than developing new ones from scratch for every subsystem. Jonathan Caldwell, Lockheed Martin's Vice President and General Manager of Strategic and Missile Defense Systems, articulated the philosophy behind the program's architecture in terms that address the recurring criticism that American hypersonic development has been too slow and too expensive relative to Chinese and Russian programs. NXGB demonstrates our commitment to delivering next-generation deterrence that is not only effective but affordable and producible at scale, Caldwell said. We designed this capability from the outset to provide greater value to our customers while delivering an operational advantage to the warfighter. Caldwell also addressed the role of institutional knowledge and the modular open systems approach in enabling the NXGB's accelerated development trajectory. The future of deterrence belongs to solutions that combine innovative modular open systems approach and modern design methods with proven performance, he said. NXGB reflects a paradigm shift focusing on design for manufacturing at scale while implementing decades of lessons learned designing, producing, and delivering mission-critical systems for the warfighter. That heritage allows us to move faster as well as reduce risk and cost while keeping exceptional performance. The modular open systems approach Caldwell references is a design framework the U.S. military has been pushing defense contractors to adopt across multiple programs, requiring that major subsystems be built to open standards that allow components to be upgraded, replaced, or swapped between platforms without redesigning the entire weapon. For a hypersonic glide body, that modularity could mean swapping guidance systems, warheads, or thermal protection materials as technology improves without requiring a new development program each time, a flexibility that has significant implications for keeping the weapon operationally relevant over a multi-decade service life. Multi-domain launch compatibility is among the NXGB's most operationally significant attributes, with Lockheed Martin stating the weapon can be launched from multiple platforms across multiple warfighting domains, meaning potential integration with ground-based launchers, surface ships, submarines, and aircraft, though the specific platforms under consideration were not identified in the announcement. That flexibility matters because it prevents adversaries from neutralizing the weapon by targeting a single launch platform type, and it allows commanders to choose the most survivable or most appropriately positioned launch option for a given mission. Lockheed Martin's investment in dedicated manufacturing infrastructure for the NXGB program reflects a lesson the defense industry has absorbed from the ammunition and missile shortfalls exposed by the Ukraine conflict and the Iran strikes. Designing a capable weapon is insufficient if the industrial base cannot produce it in the quantities that sustained operations demand. The company says it has made significant investments in purpose-built manufacturing facilities and supply chain partnerships to enable rapid production scaling, though the specific locations, investment amounts, and production rate targets remain undisclosed.